Swayam Prabha. Digital India. Educated India.
Good afternoon. Welcome to lecture number 22, part 1, numerical problems. So, we will be solving few numerical problems pertaining to the various heat loads, various components of the heat loads while we are designing the cold storage. Estimate the product load of chicken whose thermal properties are given below. The water content present in the chicken is around 66%. To be more specific, it is 65.99. Specific heat capacity above freezing is given. So, this is Cp value above freezing, 3.31 kilojoule per kg Kelvin. Initial loading temperature is 22.2 degrees centigrade. Freezing point is minus 2.8 degrees centigrade. Latent heat is given 225.6 kilojoule per kg. Specific heat below freezing. Specific heat below freezing, 1.76 kilojoule per kg Kelvin. Storage temperature is minus 16.1 and the quantity is given as 45.4 kg. So, let us solve this problem step by step. So, this is numerical question number 1. Just to recollect, in the previous lecture, I have solved one, towards the end of the lecture, I have solved one numerical question pertaining to transmission load, and this particular question is pertaining to product load. So, the product given is given data. Product is chicken. It is a dead product, not a live product. So, there will not be any respiration load. Specific heat capacity above freezing. This is above freezing Cp value. Above freezing Cp value is equal to 3.31 kilojoule per kg Kelvin. 3.31 kilojoule per kg Kelvin. Below freezing, Cp value is equal to 1.76 kilojoule per kg Kelvin. 1.76 kilojoule per kg Kelvin. Freezing point is given as TF is the freezing temperature, freezing point or freezing temperature, minus 2.8 degrees centigrade. So, here F refers to freezing point, freezing. Quantity mass that is given as 45.4 kg. 45.4 kg. And the loading temperature, water content is given as 65.99%. Let this be in one corner. Water content is equal to 65.99%. Let me write this clearly. 65.99%. F denotes freezing. F denotes freezing. So, here we need to find out Q1, Q2, Q3, Q4 will be equal to 0 because there is no respiration load for a dead product. After finding Q1, Q2, Q3, the summation of these three will give the product load. So first one is sensible heat above freezing. That is Q1. Q1 is equal to MCP delta T. That is assuming that the products are arriving in bulk. So in one of the earlier lecture, I had mentioned two types of formulas. Suppose if it is not arriving in bulk, we have to consider the packaging material also, the mass of the packaging material, that's the specific heat capacity. Since if it is not given, it is assumed that the product arrives in bulk. So Q1 equal to MCP into delta T, M into Cp into delta T. So sensible heat is above freezing into delta T. Delta T is M into Cp into initial temperature minus freezing temperature, freezing point. So let us write the value of T1 also. Value of T1 is given in the problem as initial loading temperature 22.2. T1 is given as 22.2 degree centigrade. So substituting the values, M is 45.4. Cp, we have to substitute the Cp of the product before, that is above freezing. We have to this is the Cp value above freezing. So 3.31. And temperature difference, we can substitute either in degrees centigrade or in Kelvin. So this is T1 is 22.2. So let us 22.2 minus TF is minus 2.8. So minus of minus will become plus. So if we calculate the sensible heat load above freezing comes to, so this is cooling the chicken from 22.2 to minus 2.8. That is the mean. Cooling the chicken from the initial loading temperature 22.2 to up to freezing point. So the Q1 value is 3.76. Q1 value is 3.76 kilojoule. If you see the unit MCP delta T, M is in kg, specific heat in kilojoule per kg Kelvin, temperature, it's a degree centigrade or Kelvin. Anyway, it's a difference in temperature. So temperature, Kelvin will get cancelled. Kilojoule will get cancelled. We'll get the unit as kilojoule. Only when we have mass flow rate, the unit is kg per second. So then we will get the heat quantity as kilojoule per second, which is nothing but kilowatts. So this is step 1. Okay. Sensible heating above freezing. Next one is latent heat. Latent heat load, that is Q2. This is mass of the product into H of latent heat. H of latent. So the latent heat is given as 225.6. So let us use H of LAT. H of LAT. So latent heat is H of LAT is equal to 225.6. 225.6 kilojoule per kg. This is the, because the water content is given, so we need to consider that also. If this is not given, directly we can multiply the mass of the product by the latent heat. Because this is given, so we need to consider that one into water content. If water content is not given, it is assumed as 100% or 1. This is equal to 45.4 into 225.6 into 65.99 percentage, that is divided by 100, which is nothing but 0.6599. So when we calculate, we get the latent heat load as, this is what with latent heat of fusion with 65% of water content. Now let us calculate Q2, that is the latent heat. Latent heat, that is Q2, that is mass of the product into latent heat multiplied by the water content. Since this is given in the question, so it is given as 65.99%. 65.99%. This is given as 65.99%, 99%, which is equal to 0.6599. Mass of the product is given. So substituting the values, we get Q2 is equal to 10.04 kilojoule. 10.04 kilojoule. 10.04 kilojoule. Next, we have to calculate the sensible heat load below freezing. Below freezing. Sensible heat load below freezing. So that is Q3. That is equal to mass into Cp. Here we need to ensure that we are substituting the value of Cp below freezing. There are two values of specific heat capacity. One is above freezing and another one is below freezing. Into delta T. Delta T is from freezing to temperature T2. Temperature T2. T2 is given, that is from freezing to minus 16.1. So that temperature is also given in the numerical question, that is 16 point storage temperature. Storage temperature. Storage temperature. So this is T2. This is T2. So let me write it here also. T2 is minus 16.1 degree centigrade. So substituting the values, we'll get M is equal to 45.4. So you can substitute the values. This is cooling from, see, Q1 is cooling from 22.2 to minus 2.8. Then at the freezing point, the latent heat of fusion with 65.99% of water content. Then for Q3, it is cooling from the freezing point till minus 16.1. Minus 16. So the temperature only have to be substituted. So this is TF, this is T2, and the specific capacity, this is Cp value below freezing. Cp value below freezing. So substituting the values, we will get Q3 as 1.06 kilojoule. Substitute the values. We will get Q3 values of M, Cp, this is below freezing, TF, T2, we get Q3 is equal to 1.06 kilojoule. 1.06 kilojoule. 1.06 kilojoule. The respiration load is 0. That is respiration load Q4 is equal to 0. Since chicken is a dead product, since chicken is a dead product, it is not a live product. Q4 is equal to 0. Now the product load is equal to, the total product load is equal to, that is Q suffix P, which is equal to Q1 plus Q2 plus Q3 plus Q4, which is equal to Q1 is in the previous slide 3.76 kilojoule, 3.76 plus Q2 is 10.04 plus Q3 is 1.06, Q4 is 0. So the total product load comes to 14.86 kilojoule. 14.86 kilojoule. So that completes the problem. Let us move to the second numerical question. Green peas of 22.7 kg need to be cooled from 29.4 degrees centigrade to 4.4 degrees centigrade and stored at 4.4 degrees centigrade. Specific capacity above freezing is given. Heat of respiration is given. So we have to determine the product load. Let us solve this problem. So this is numerical question number 2. It is question number 2. So mass is given 22.7 kg. Mass is 22.7 kg. Product is green peas. Product is green peas. So it is to be cooled from 29.4 to 4 degrees centigrade and it is stored at 4.4. Specific capacity above freezing 3.77. CP value, this is above freezing. .77 kilojoule per kg Kelvin. Heat of respiration, that is 0.38 kilojoule per kg. Heat of respiration, H of RES. It is given as 0.38 kilojoule per kg. So 0.38 kilojoule of heat of respiration for 1 kg of per kg of green peas. We have to determine the product load. So T1 is given as 29.4 and TF, this is, so it has to be cooled up to 4.4. It is not TF, it is just above freezing, above freezing. So what we can do is, instead of taking TF, we can take this as T1 minus T2, but let it be like that. Since the cooling process is done above freezing, since the formulas for above freezing we are using T1 minus TF, so let us use the same notation. So T1 is equal to 29.9 degrees centigrade. TF is equal to 4.4 degree centigrade. Here it is cooled, product is cooled above free up to above, product is cooled up to 4.4 degrees centigrade above freezing. above freezing point. Above freezing point. So let us calculate the sensible heat above freezing. Sensible heat above freezing. Q1 is equal to M into Cp into T1 minus Tf. So this is equal to M is 22.7. Cp, there is only one value of Cp is given, that is above freezing. So that is 3.77 into delta T. T1 is 29.9. T2 is, Tf is 4.4. Though it is not the freezing point, since we are using the formula, the standard formula, so we are taking T1 and Tf. So it is cooling from 29.4 to 4.4. So 29.9 to 4.4. So this is equal to Q1 comes to 2.14 kilojoule. 2.14 kilojoule. If you look at the question, there is no details about below freezing point or freezing point. So therefore, Q2 and Q3 are 0 because since the product is stored above the freezing point. Q2 and Q3 are 0 since the storage is above freezing point. Q2 is equal to 0 and Q3 equal to 0 since the product storage is above the freezing point. Now let us calculate Q4, which is the respiration load, because green peas is a vegetable which is a live product, Respiration load Q4 is equal to mass multiplied by the heat of respiration. So that is, both are given. Heat of respiration is given as 0.38 kilojoule per kg. So substitute the value. So this is equal to 22.7 into heat of respiration is 0.38 kilojoule per kg. So when we calculate, we get Q4 is equal to 8.63 kilojoule. 8.63 kilojoule. Now the total product load is equal to Q suffix P is equal to Q1 plus Q2 plus Q3 plus Q4, which is equal to Q1 is 2.14, Q2 and Q3 are 0, Q2 0, Q3 0, plus 0 plus 0, plus Q4 is 8.63 kilojoule. 8.63 kilojoule. So when we calculate, we get the total product load comes to 10.77 kilojoule. 10.77 kilojoule. So if we compare the problems, problem number 1 and numerical question number 1 and 2 that we have solved in this lecture, in both the problems, we need to estimate the product load. In the first problem, because chicken is a dead product, there is no respiration load. The data was given above freezing at freezing point and below freezing. So we calculated Q1, Q2 and Q3. Q4 is equal to 0. And in this problem, there is only one type of sensible heat load, that is above freezing. No details, because the cooling is done above the freezing point. So there is no latent heat load, that is Q2 equal to 0. And there is no sensible heat load below freezing, which is also, that Q3 is also 0. But there, because Greenpeace is a live product for which respiration load is applicable, so Q4 is not equal to 0. We have calculated Q4, and the total product load is the summation of Q1 and Q4 only for this problem, as Q2 and Q3 are 0. So I will stop this lecture at this point. Thank you.